Have you ever wondered what's really holding a massive piece of business software together? Well, today we're going to pull back the curtain and look at the actual architectural blueprint that stops modern B2B software from completely falling apart. This is the deep down engineering that makes it all possible. So this is the central question, right? And it is a huge one. We're not talking about some simple app on your phone. We're talking about a single system that has to securely handle the private data for thousands, literally thousands of different companies, what we call tenants, all at the same time. The scale is just massive, and the stakes incredibly high. And this right here, this is the nightmare scenario. It's the monster under the bed for every software architect, the big ball of mud. It's what happens when your application gets so tangled up that changing one tiny thing over here somehow causes a catastrophic failure in a totally different part of the system. It's the fastest way to build something that's just impossible to maintain. Okay, so how do we avoid that disaster? We're going to follow this roadmap. First, we'll dig into the unique challenges that B2B software faces. Then we'll pull back the curtain on the blueprint designed for stability. From there, we'll look at the smart patterns that keep data safe, watch it all come together in action. And finally, we'll tackle the elephant in the room, the big microservices question. All right, first up, let's break down the specific problems that make building software for businesses so darn complex. You know, it's a completely different beast than building something for individual people. So when you look at these challenges, it's really all about the stakes. Data isolation isn't just a feature. A single bug could leak one company's secret financial data to a competitor. Maintainability means, can you grow without having to rewrite the whole thing every year? Operational complexity, that's the silent killer that can sink your company with server costs. And performance, come on. If your dashboards are slow, your customers are just going to find another tool. Simple as that. So with those challenges fresh in our minds, now we can introduce the solution. And this isn't just some random collection of hot technologies. It's a deliberate, almost elegant blueprint designed specifically to bring order to all of that potential chaos. And here it is, the solution. A modular monolith on the back end, talking to a totally decoupled single-page application on the front end. Now, I know that sounds like a bit of a mouthful, so let's break down exactly what this means and why it's actually so powerful. Okay, so this term, modular monolith, or monolith, is key. The whole point is that you get the best of both worlds. You get one single application that's simple to develop and deploy. That's the monolith part. But on the inside, it's built with these super strict, clean walls between its different parts, like billing or security. That gives you the organization of microservices, but without all the complexity. And this perfectly shows the decoupled part. The whole system split into 3 distinct layers. You've got the front end, which only cares about what the user sees and clicks. You've got the back end, which only cares about the business rules and security. And you've got the data tier, which just holds the data. They only talk to each other through well-defined APIs, which means you can completely change or scale one of them without breaking the others. Look, a great blueprint is one thing, but you need the right techniques to actually bring it to life. So now, let's dive into a couple of the key engineering patterns that make this whole architecture so secure and so robust. First up is something called a data transfer object, or DTO. The easiest way to think about it is as a carefully crafted package for sending your data. So instead of just exposing your messy internal database structure to the whole world, you use a DTO. Why is that a big deal? Well, it means you can totally reorganize your database, and as long as that DTO looks the same, your front-end app won't have a clue. It's a critical safety barrier. Next, we have interceptors. I love these. Think of them as automated security guards. Every single time a piece of data tries to move through the system, an interceptor can jump in, check its credentials, and add any necessary information, like which company this data belongs to. The best part is, it does this automatically, so your developers don't have to remember to do it every single time. Here's a super simple example. A user clicks a button. Before that request even leaves their browser, an interceptor grabs it, slaps on their security token, and their company's unique ID. By the time that request gets to the backend server, it already has all the context it needs to be handled securely and correctly. It's simple, it's powerful, and it's automatic. So we've seen the blueprint and we've seen the patterns. Now for the really fun part. Let's follow a single user request from the second they click their mouse all the way down into the database just to see how all these pieces work together so perfectly. So let's trace the data. It starts with a click on Save. Instantly, a front-end interceptor adds the company ID. The back end then checks security, makes sure the request is legit. Then the data gets packaged into that safe DTO we talked about, and the business rules get applied. Things like making sure a salary isn't a negative number. And then, finally, as the data gets saved, a powerful automatic filter makes absolutely certain the correct company ID is attached, guaranteeing it goes to the right place. Every step is a checkpoint. Okay, so we've seen how this system keeps everything in order. But you might be wondering, why this specific architecture? And that's a great question. It was a very deliberate choice. So let's get into the why by looking at the major trade-offs that were made. The elephant in the room is always microservices. And look, they have their place. If you need to scale one tiny component to the moon, they're great. But for most B2B applications, they introduce a world of pain, network issues, distributed transactions, massive operational overhead, stuff you just don't need. The Modular Monolith gives you those clean boundaries and simple deployment, making it the right choice for the vast majority of apps out there. The other big fork in the road is how you store the data. You could give every single one of your customers their own separate database. That's incredibly secure, sure. But just imagine you have 10,000 customers and you need to add one new column to a table. You'd have to run 10,000 database updates. It's an operational nightmare. The approach chosen here, a single database for everyone, is way cheaper and easier to manage, as long as you have an absolutely ironclad way to keep the data separate. And this right here is that ironclad safeguard. This is the magic that makes the whole shared database idea possible. A technology called Hibernate Filters automatically intercepts every single query for data and adds one simple condition, where tenant ID equals the current company's ID. This makes it programmatically impossible for a query for company A to accidentally get data from company B. It just can't happen. So there we have it. We've seen the blueprint, the what, and we understand the major trade-offs behind it, the why. But that leaves us with one final, really important question. Right, we've mentioned these automatic filters and context holders, but how do they really work under the hood? How can the system be so sure from one moment to the next which company is which so that data never ever gets mixed up? Well, that is a fantastic question, and it's exactly what we're going to break down in our next explainer. I'll see you then.